Welcome to our tutorial on understanding 3D game physics. Whether you're a seasoned developer or just starting out, this video will guide you through the fascinating world of physics in game development. First off, let's discuss what game physics is and why it is crucial for 3D games. Game physics simulates real-world laws, like gravity, friction, and collision detection, to create an immersive experience for players. In this video, we'll cover key concepts such as forces, motion, collision detection, and responses in 3D environments. By the end, you'll have a solid foundation to understand how to implement physics in your games. Let's start with the basic principles of physics, Newton's laws of motion. These laws govern how objects move and interact in a 3D space. Newton's first law, an object in motion stays in motion. This implies that if no forces act on an object, it will continue moving in a straight line at a constant speed. Now, how do we enforce this in code? Let's create a simple physics engine in Java that applies this principle to an object. In the rigid body class, we have a method called update that alters the position of an object based on its velocity. The delta time parameter represents the time passed since the last frame. Next, let's look at forces and how they affect motion. In the game physics world, forces can be anything from gravitational pull to user input. We can represent forces in code. Here, we apply a force to the rigid body, modifying its velocity based on its mass. An important thing to note here is that the acceleration is computed by dividing the force by the body's mass. Now that we have an understanding of motion and forces, let's introduce gravity. Gravity is a force that attracts an object toward the center of the Earth or any other celestial body. As you can see, we apply gravity as a downward force. The constant -9.81 is the gravitational constant in meters per second squared, m/s superscript 2. This updates the object's velocity and position accordingly. Next up, we'll talk about collision detection. In 3D games, we need to determine when objects collide and respond appropriately to these events. The check collision method checks if two objects are overlapping. The distance between their centers is compared with the sum of their bounding radii. For collision response, we can use a basic physics-based approach. Upon collision, objects should react by altering their velocities in a way that simulates bouncing off of each other. In this method, we normalize the direction vector between the two objects and adjust their velocities based on the collision angle. Coefficient of restitution determines how bouncy the collision is. We've covered basic principles so far. Now let's talk about integrating physics into a game loop. A game loop allows us to update game mechanics, including physics calculations, every frame. The game loop method continuously updates the physics and render methods, facilitating smooth motion and interactions. Make sure to handle the delta time carefully to achieve stable updates regardless of the frame rate. Now let's put all our knowledge together. In this segment, we'll create a simple simulation of a bouncing ball subjected to gravity, complete with collision detection against a ground plane. What we have here is a game loop that applies gravity, updates the ball's position, checks for collision with the ground plane, and then responds accordingly. With all these components put together, we truly unlock the secrets of 3D game physics. Experiment with different values and parameters to see how they affect gameplay. Understanding these concepts is key to creating realistic experiences. Before we wrap up, remember that physics engines can be complex, but starting from these basics gives you a robust understanding. Many game engines, like Unity and Unreal, have built-in physics engines too, so you can take what you've learned and adapt it to these tools. Thank you for joining me today. If you found this tutorial helpful, do share, like, and subscribe for more game development tutorials. Keep coding and happy gaming!